Hey everyone, this video is the warm-up for lesson 8 of our unit 6. And so we're going to go ahead and go over these 3 problems, but before we do, there is not an actual video for the lesson because the activity that we're doing is just that, it's an activity. You're going to be matching equations with graphs, with x-intercepts, with vertices. You're going to just be matching up cards. And at first it's going to seem a little bit complicated, but once you get into the swing of it, it's going to get really quick and really easy. Don't be lazy on this activity though. When it is asking you to find the x-intercepts, actually do the work in order to get the practice on the x-intercepts. Don't just look at the graph and go, okay, that one has the right x-intercepts, so that one must match these guys. Make sure you're showing the work that gets you to the x-intercepts. Now, I would recommend matching everything up as quickly as you can and then doing the work to justify why your answers were what they are. And then you can always check the answer key to see if you're right in the end. But let's go ahead and go over these 3 warm-ups before we get into that activity. Question number 1 says, how many real solutions are there to the equation 3x squared plus 7x plus 5 equals 0. So you remember that in order to know how many solutions we have to look at the quadratic formula. Specifically, we have to look at the discriminant part of the quadratic formula. So if I were to write out the quadratic formula, it would say x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, remember, we don't really care what the answer is. We just want to know how many real solutions there are. So that is determined by what's inside the radical, and that was called the discriminant. Okay? And so the discriminant, again, discriminates between real solutions and imaginary solutions. So if the discriminant is positive, that means we're taking the square root of a positive number. Well, we're allowed to do that in real numbers. So we would end up with 2 real solutions here, okay? If we take the square root of 0, then we would have 1 real solution. Because remember, when you take the square root of, let's say, 4, you get 2 or negative 2, so you get 2 real solutions. If you take the square root of 0, what do you get? Positive 0 and negative 0, that's the same thing. 0 doesn't have a sign to it, so that's why we have 1 real solution. And then if you have the square root of a negative number, that is actually an imaginary solution. So we would say there is two imaginary solutions, but that also means that we have 0 real solutions. Okay? So it's all about what's happening with, if I could spell here, solutions. Okay, it's all about what's happening with the discriminant. So let's go ahead and find that. A is 3, B is 7, and C is 5, according to our equation up here. So we just plug that into the discriminant. We end up with 7 squared minus 4 times 3 times 5. Simplifying that, you get 49 minus 60, and then that would be negative 11. So remember though, so we'd say the discriminant is negative 11, but remember, we're taking the square root of that ultimately. Well, the square root of a negative number is imaginary, so therefore we have 2 imaginary solutions. So we have 0 real solutions for number 1. Okay? For number 2, it says, what is a function? Let's see here. What is a function that represents the area of a rectangle whose length is 5 units longer than 3 times its width? The length, let me write this down, is 5 units longer than 3 times its width. 5 units longer than 3 times its width. So we have a rectangle, and we have the length and the width, and we are looking for the area of this guy. Now remember, the area is equal to length times width. Well, we want to get a function that represents that in respect to one variable. A function has to have one variable in it. So I'm going to write an equation based on this guy. the length is, so we'd say L equals 5 units longer. So that means we are adding 5 to something, 5 units more than 3 times its width. So we're multiplying the 3 times the W. So the length is 3W plus 5, and then we can just plug that in here. So area is equal to 3W plus 5. We replace the L with that, and then times W. Now that is the area equation. If I'm going to write it as a function, I'd say the area in respect to W is equal to this guy, and we always like writing it in standard form. So I'm going to go ahead and distribute that. That becomes 3W squared plus 5W in standard form. So that is my area for a rectangle with that attribute there. Okay. Number three, it says solve by factoring. We have 20x squared minus 7x minus 3 equals 0. And we're trying to solve this by factoring. Well, the first thing I note is that when I go to factor here, the a value is really big. So I know that I'm going to have to do this thing here. So the thing that goes on top, remember, is a times c. So that'd be 20 times negative 3, so negative 60. The thing on the bottom is negative 7. So we're going to go ahead and list our factors of 60. We may be able to see it really fast, but maybe we can't. So we would say 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7 doesn't factor out of that, 8 doesn't factor out of that, 9 doesn't factor out of that, and then 10 would be back to 6. So now we'd be repeating our factors here. So which one of these produces a 7? Looks like 5 and 12 will produce a 7 when I add it. So I know that they need to add up to negative 7, which means that the 12 has to be negative and the 5 has to be positive. And to check that, positive times a negative is a negative. So then I'm going to expand this to say 20x squared plus 5x minus 12x minus 3 equals 0. And then I'd group. So the greatest common factor out of those two is 5x. What's left over is 4x plus 1. The greatest common factor out of negative 12x and negative 3 is 3. And then now we always got to look at signs and make sure we get our signs right. I need a positive 4x inside. Since this is negative 12, and the inside needs to have a factor of 4x, positive 4, then this has to be a negative, because a negative divided by negative does give me a positive 4x. And then if I divide negative 3 from negative 3, I get positive 1. So this means I did do it right because what's inside the parentheses match. The greatest common factor now out of these groups is 4x plus 1. And what would be left over is the 5x minus 3. And that would be equal to 0. We always do want to check our work. If we distribute this all back out, we want to make sure that it matches our original standard form. From here, we apply the zero product property. So we'd say 5x minus 3 equals 0, and 4x plus 1 equals 0, and then solve each one of those. So we'll add 3 here. Get 5x equals 3. We divide by 5, so x equals 3/5. And in this case, we'll subtract 1, so 4x equals negative 1. We'll divide by 4, so x equals negative 1/4. Now it just says to solve. So our solutions are our x values. So x equals negative 1/4 and 3/5. And that is the answer to number 3. So go ahead and get started on your activity. And hopefully it makes sense to you. Make sure you guys are working collaboratively. Make sure you're staying on task. Make sure you get this job done before the end of the period. And have a great day.